Camera movement! Hey boy, okay. There's a ton of projects that will require a ton of time to set up a fully functional camera system. But in our case, this is not the main gameplay element of our game, and the camera movement is pretty simple to do. So we should be able to do it all in one video, and it is what we're going to do today. So we're going to open the pawn. Here in the viewport tab, so let's say if you're in there, you can click on viewport. I'm going to add a few components because right now the pawn is pretty empty. There's just the default root here. So I'm going to add a few components. The first one we're going to need is a camera because we're going to use this pawn as our main camera. So in the top left corner, we can add a component and we can scroll down to find the camera right here. So camera, click on it to add it. When you select the camera on the right side, you can adjust all the settings that you want. So let's say you want an orthographic camera instead of a perspective camera, or if you want to adjust the field of view, or if you have any post-process setting that you want to set also. But right now I'm just going to leave it as is because the default settings are pretty good for us. And the second component I'm going to need is the spring arm. So I'm going to add another component and I'm going to scroll until the camera section here and click on spring arm. And I have all the components that I need for now. So I have the spring arm and the camera. Right now my camera is not placed at the right position because I want it to be under the spring arm, which is the opposite of what we have right now. So I'm just going to take the spring arm and detach it from the camera by dragging it onto the camera. So it's going to detach it from it. And then I'm going to take the camera and attach it to the spring arm, which moves it in the viewport. The reason why it moved is because if I select the spring arm, I can see the red line here. It moved the camera to the end of the spring arm. So this is the length of the whole spring arm and it placed the camera right after it. This feature is pretty cool because it's going to help us build our zoom or camera zoom because let's say if you go on the right side here, there's the target arm length. If you change that value here, you can see the camera moving. And we're going to use it to zoom out and zoom back in. But for now, I'm just going to let it to a value of 700. It doesn't really matter. While we are in the spring arm, there's a few other settings that I want to change. So the first one is the do collision test. I want it to be false because what it does is if there's an obstacle in between the root of the spring arm and the camera, it's going to move the camera forward until it's not blocked by that obstacle anymore. Which is not a behavior that we want to have right now. We can add it in the future if we want to, but for now I'm just going to disable it. It's going to help us build our own camera without having to deal with some less predictable movement, let's say. And the last setting is the camera orientation, because right now it's flat with the ground. So let's say the grid is my ground here, so I'm going to have my grid in game on the top of it, and I'm going to have my units walking around. So I want my camera to be able to look at the grid, not be flat on the grid, because it's not really useful for us. So I'm just going to, in the spring arm still, I'm going to rotate it. So I'm going to rotate it on the y-axis, which is going to affect the pitch, and I'm going to place it to -60. You can also change it on the right if you want to. So rotation in y -60. You can make it -70, 80, 90. You can use the value you want. But for me, I really like -60. So that's what I'm gonna use. And that's it for the components. So I can compile, save the blueprint, go back to my entry level, and then I can test and see how it looks in game. So I'm going to press play. We are in the air a little bit, and we're looking down towards the grid. If we want to see this in more details, we can simply eject. Here at the top, there's a big eject button, and then we can move around like we were in the editor, like without the game playing. Since we didn't stop the game, it means that we still have access to all the actors that were spawned after the game started. So we have our game mode, our pawn, and our player controller. If I select my pawn here, I can now see that there's the spring arm right here. It's looking towards the ground, like we said. And at the top here, there's the camera. We don't see it because it's hidden in game, but there is the camera here that is looking downwards. And we can see the preview on the right here. So that's good. We have our camera and the angle that we want to use while playing the game. Perfect. Let's stop and go back in the pawn. So let's now move the camera at runtime. The first thing we're going to do is the camera zoom, because we have most of the logic already handled by the target arm length here. So let's say we want to zoom in or zoom out. the only thing we have to change is that value over here, the target arm length. And then Unreal is going to adjust the camera for us. So let's go in the event graph here. Here we have all the default events, which I don't want, so I'm just going to delete them. Perfect. Now we have an empty event graph. In my case, I want to be able to control the zoom with my mouse wheel, like in the editor. So how do we access that? Well, we can simply right-click and search for mouse wheel. And here we have a few events. The one that we could use is the mouse wheel axis, so let's click on it for now, and we have it here, right here. This event is automatically called by Unreal and it will work perfectly, but it's not really the best options. Because let's say you have a controller and a mouse, and let's say you want to be able to zoom with, I don't know, the keyboard. Well, you don't want to have to create all those events right here and then link them together to end up with the same result. It will be a bit messy, I think. And this is exactly why Unreal already has a setup to handle multiple inputs that controls the same event. And we're going to use it. So let's delete that event right here. And we go in the project settings. If you closed it, you can always reopen it with Edit, Project Settings. In here we can go on the left and go in the category Input. At the top, in the bindings, we have two options for us, the axis or the action. Right now we want to have an axis, so I'm going to add an axis and expand it. In here we can name it. I'm going to name it input axis underscore zoom, so it's going to be the axis for my zoom, and I'm going to expand it. This is where we can select the button we want to use, so I'm going to click it and go in mouse, and I want the mouse wheel axis. Perfect. And let's say I wanted my game to be compatible with a controller. I can simply add another input right here with the plus button, and then I can select in the gamepad section right here. I could select, I don't know, left thumbstick up, which would also send the value to that event. So we can have multiple inputs controlling the same event. So let's say I have a gesture right here that controls the same event, or let's say, I don't know, something on Daydream. Doesn't matter. It will all call the same event, so all my inputs are centralized by Unreal itself. But for now, I don't care about any other platform, so I'm just going to delete them. Delete and delete. We can go back to the pawn. We should be able to find the event that we just created, so input axis zoom. Let's click on the first one. And this is how this event works. It's called every frame by Unreal, and it lets us know how much the user scrolled in that frame. So we can use that value to affect the zoom of our camera. But first, let's just see how it looks. So I'm going to drag from the white pin right here, and I'm going to search for print string. Here we go. Then we can drag off axis value and drop it on the string here. Unreal is going to create a conversion node for us. This is because the value on the left in green is a float, which is a number, and on the right is a string, which is text. So Unreal is converting the number into text for us, which is fine. So let's compile, save, go back to the level and press play. Here on the left we see all the numbers, which is 0 right now because I'm not scrolling on my mouse. If I scroll out, here I can see minus, minus, minus 1, minus 2, minus 3, depending on the speed at which I'm scrolling. And if I scroll the other way, I can see 1, 2, 1, 2, 1, 2, 1, 2. I can't quite reach any other numbers. So yeah, when I'm scrolling out, I see numbers. When I'm scrolling in, I see numbers. Perfect, we can use those numbers. So let's stop. And go back in the pawn and delete this. So as I said, the objective is to modify that value over here, the target arm length, which is in the spring arm component. So let's take it. I'm going to drag the spring arm component and drop it in the graph. So now I have a reference to that component. From that component, I want to set the target arm length. And it is exactly what we're going to do. So drag from the component and search for set target arm length. Here we go, enter. So what the value do we want to use for the target arm length? Well, we can't really use the axis value directly because it's -1, -2, -3, +2, +4. Like, it's not good enough. Like, we add a value of 700 in there. It's not gonna work if we use -3 for it. But what we can do is use that 700 and then add on to it. And that's what we're gonna do. So I'm going to take from the spring arm, and this time I'm going to get the target arm length. I'm going to get the first one, which is the get. Here we go. And now from the target arm length, I can drag out of it and search for plus and take the float plus float function right here. For the second float, I can use the axis value. And we can take the output of the addition and use it to set the length. Make sure to connect the event to the set, otherwise the code won't be called. And we can go try that. So compile, save, go back in the main level, press play. So now if I zoom out, well, it moves. And if I zoom in, it moves also. So if I zoom super fast, I can move my camera. I can zoom in and zoom out. The first thing I noticed, other than that it's super slow, is that it's inverted. So let's say if I zoom out, my camera moves in. But if I zoom in, my camera goes out. So we're gonna fix that. So we're going to go in the project settings. In our zoom mouse wheel axis right here, there's a scale of 1, but we want to invert it. So we're going to use -1. So it's going to multiply that value by -1. And we can go try it right now. So play and scroll in, it goes in, scroll out, it goes out. Perfect. But now let's fix the speed, because it's way too slow and it's annoying. So I'm going back in the palm. The slow speed is caused by this axis value right here. It's super low. It's -1, -2, it's so slow. So let's multiply it. I'm going to move this a little bit to the right. And then right here, I'm going to drag from the axis value. And I'm going to search for a star, which is the multiply symbol. Then I'm going to take the float times float function. And I'm going to add a speed in there. Let's say 40. And then we can use the output of the multiplication into the addition, instead of using the axis value directly. Let's go test this. So compile, save, go back to the level, press play. So now if I zoom out, okay, it goes fast. If I zoom back in, it goes fast also. Perfect. So now we can zoom in and zoom out. Oh, I'm far. That's not good. I think we need to limit that. Otherwise the player is going to be like, I'm out of here. That's not what we want. So let's stop. Go back in the palm. Here, before setting the arm length, we're going to clamp it, which simply means to limit it. So I'm going to drag from the output here and search for clamp, C-L-A-M-P. And I'm going to use clamp float right here. So what this function does, it's going to take the output of the addition right here, so the value, and it's going to limit it between the minimum and the maximum value we're giving it. So right now it's 0 and 1, which doesn't make sense. But let's say for the camera, we want it to be, let's say 100 away from the floor at minimum, and maximum, let's say 5,000 units in the air. I think that makes sense. And then I can take the return value of this function and connect it to the target arm length. And go test it. So compile, save, level, play. So now if I zoom forward, okay, that's good. I cannot go through the floor anymore, so that's good. And then if I go out, okay, this is the furthest I can go, which is good. Perfect, that's great. Okay, good, good. We have a zoom. It's fine, but it's super snappy. Like, look at it, like stack, tack, 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 tack. So the thing we can do is interpolate between this point right here and this next point. It's going to take a bit more time to reach the destination, but it doesn't matter. So let's say instead of going here in like 0.5 seconds, we can go there in like 2 seconds, but it's going to be super smooth. So let's do that. I'm going to go back in the palm, so stop, palm. To do this, we're going to shuffle a few things around. So first, we're not going to set the target arm length directly. We're going to set it into a variable and then use that variable to smoothly interpolate to the target arm length. So let's do this. Right click on the return value right here, and I can do promote to variable, which is going to create a new variable for us. The name right now is new var0, which is bad, so let's rename it. It's right here on the left. So let's select it, press F2, and type a name. Let's say zoom underscore desired, because this is the desired zoom. So instead of setting the target arm length, I'm going to set the desired zoom. So just connect it right here instead of the target arm length. We don't want the target arm length connected to the clamp anymore, so we're just gonna break it. You can right click and click on break if you'd like to. But the best way is to simply hold Alt and then click on the node. Then I'm going to bring that closer right here. And we're gonna do the same thing. We don't really want to use the target arm length to modify our zoom desired. So we're going to replace this. On the left, I can take the zoom desired drag it into the graph and do a get zoom desired. Then I can connect the zoom desired to the addition and move it closer. So right now the event doesn't affect the camera anymore. It simply increases or decreases this value that we're going to use later to move our camera. So this is the camera. We can go back and try this out. So save, compile, press play. If I zoom out, nothing happens. If I zoom in, nothing happens. But the value changes in the back. So let's hook that value. I'm going to stop, go back in the palm. To interpolate, we're going to use the tick, which is an event that is called every frame. We can access it by right-clicking, search for tick, and select the event tick. Then we're going to hook it to the target arm length, right here. And then we're going to do the interpolation, which is already a function that exists in Unreal. To access it, we can drag from the input of the target arm length right here. So drag backward and search for interp2. We're going to use finterp2. This function takes a few inputs. So it takes the current value, which is the target arm length that we have right here. The target, we want the desired zoom. So we're going to drag it from the left and drop it on the target. Then we need the delta time, which we can get from the tick right here with the delta seconds. So we're just gonna connect them together. And finally the interp speed. Let's say 2 for now. You can adjust that if you want. Let's try this. Compile, save. Go back to the entry, press play. Okay, my camera moved. That's a bit weird. Okay, but let's say if I move out, zoom out. Okay, good, it seems smooth. Zoom back in, it's pretty smooth. Okay, if I do small movements, oh, that's smooth, that's nice. Okay, great. So that's a pretty good zoom. Perfect. Let's stop. Let's play again. My camera moved again. That's a bit odd. And we have to fix that. So stop, play. Okay, what happens? Well, the camera's moving to 0, 0, 0, I guess. Close to 0 at least. Okay, what could cause that? Stop, go back in the palm. Every frame, the zoom desired here is taken, adding the value of the zoom, clamped between 100 and 5000, set the zoom. Perfect. Every frame in the tick, same thing. Take the target arm length, interpolate to the target, which is the zoom desired, set the arm length. Okay, that makes sense. But what is the value of desired zoom? Right now it is 0. Right here on the right, you can see the default value is 0. Okay, so that's why. When the game starts, my value here is 0. I'm adding the value of the zoom, which is 0 because I'm not zooming at the beginning of the game. And then I'm clamping it between 100 and 5000. Okay, so it's 100. Otherwise it will be 0. So perfect, it's 100. And then setting it to desired zoom. So it explains why my camera at the beginning of the game goes to 100, which makes sense. So let's fix this. I can select the desired zoom right here, or on the left, same thing, can select it, and set a default value. The default value should be the same value as the default length of the spring arm. So let's say if I select my spring arm component on the left right here, I have my target arm length, which is 700. I should use that same value to set the zoom desired. So that's where we're gonna do. So 700 for the default value of the zoom desired. Let's compile, save, and go back in the level and press play. Here we go, my camera doesn't move on start. And if I zoom out, it works, and I zoom back in, it works also. Perfect, we now have our zoom done. The next thing we have to do is the location of the camera. We're going to do something pretty similar to what we did for the zoom. So I'm just going to move the zoom stuff down here because I think it makes more sense to have the tick above it. And then we're going to go back in the project settings. In here, we're going to add one more axis that I'm gonna name input axis underscore forward, which we're going to use for the forward and backward movement of the camera. For the keys, we're going to use the W for forward and the S key for backward. We're also going to add the up arrow, up, and the down arrow. As for the scale, we're going to use 1 for forward, -1 for backward. So the S is going to be -1. The up is forward, so it's 1, and down is backward, so it's gonna be -1. So that's it for forward and backward. Now we're gonna add another axis mapping for the left and right movement. So input axis right. Same thing, we're going to have 4 keys. The first one is going to be D. Second one, A. Then the right arrow. And finally the left arrow. Same thing for the scale, so 1, -1 for the A, 1 for right, and -1 for left. Here we go. We can now go back in the pawn. And we can create the events for our axis, so input axis forward and input axis right. Up here, okay. Same thing as for the zoom, we're gonna multiply that axis value. So I'm just gonna copy paste the multiply here with Ctrl+C, Ctrl+V. And then we're gonna need a variable to set our desired location. So we're gonna create a new variable. Here you can come on the left side and click on plus variable right here. We can give it a name, so location underscore desired. By default, the variable type is a boolean, but we want to use a vector, so we're just gonna go and change it. To do that, we can select the variable and go on the top right corner. Here we can see boolean, we can change it to a vector, and then we can compile the blueprint. Once the blueprint is compiled, on the right side right here we can see the content of a vector. So if you don't know, a vector is 3 float combined together in the same variable. So in our case, since it's a location, it's the X coordinate, the Y coordinate, and the Z coordinate. And that's exactly what we need. So we're gonna go back on the left side, get the location desired, and drag it in the graph. We're gonna select set. And then same thing as for the zoom, we have to get the variable, then add the result of the multiplication of the axis value. So we're gonna go back on the left side, get the location, drag it here, get. Then we're gonna add, so plus. We're gonna do vector plus vector, and we're gonna plug it into the desired location. We can also attach this back to the event. Here we can see that we have a float on the left side, because it's green, and a vector on the right side. We could connect them together, but it's not what we want. We want to be able to specify which axis we want to affect with that float. And to do that, we can simply right-click on the vector here and choose Split Struct Pin, which is going to split the X, Y, and Z axes into 3 floats. Then we can take the result of the multiplication right here and attach it into the X, because this is the forward direction in Unreal. We can now do the same thing for the right. So I'm gonna copy, paste all those nodes right here. I'm going to attach the set into the event. And this time I'm going to take the result of the multiplication and put it into the Y, because it's the right axis. Now we have to go in the tick and use the desired location to affect our camera. And we're gonna do the same thing. So we're gonna use an interp node. If I right click right here, I can search for interp 2, which is going to show me all the interp nodes that exist. We have the F interp for a float, the R interp for a rotator, and the V interp for the vector. In our case, it is a vector, so we're gonna take the V interp 2. We already know the target, which is the location desired that we just did, right here. And we have the delta time from the tick, so I'm going to attach it right there. As for the speed, I'm going to use 5, just like this. Then we have to apply the result right here to the camera. So how do we do that? Well, we have the camera right here. We don't really want to move the camera directly because it's controlled by a spring arm. That spring arm, maybe we can move that, or the same thing, we can move the actor itself. Right now I'm selecting the default scene route, but I mean the actor in the level. And I think that's the simplest thing to do, so let's do it. So first we get the actor location, pass it into the current, and then we set the actor location again. Same thing that we did for the arm length. To get the actor location, it's easy, get actor location. Here we go, the second one right here. And we can attach it to the current. And same thing for the set actor location. Set actor location right here. Then we can hook all that up together. And this should move the camera. So let's try it. Compile, save, go back in the level, press play. Okay, the camera moved, so that's a good sign, I guess. Okay. And then if I press right, I move. Press left, I move. Down, up. Okay, so that's good. It seems to work, so I can move left, right, up, down, using either the WASD keys or the arrow on my keyboard. But it's a bit fast, so we're gonna slow it down a little bit. Go back in the pawn. If I go back down here, where I get my input axis, I'm multiplying by 40, let's say 20 instead. Multiply by 20. Okay, that should fix up the speed. Compile, save, and go back in the level. Okay, the camera moved again. We're gonna have to fix that. But let's check the speed. Right, left, down, forward. Okay, it's better. It's more manageable. Good. Okay, now for that movement right here. Where does it come from? Well, it's the same thing we had for the zoom. The default value of the desired zoom was not the same as the default value of the target arm length. And that's what caused the problem before. And this is the same issue. If I go back in the level and I look at my player start right here, this is where my pawn spawns. And right now we can see that the value is 0 in X, 0 in Y, and 112 in Z. So let's say I copy the 112 in Z, and I go back in the pawn, select my location desired, and paste it right there. Boom. So now my location desired should start at 112. Compile, save, and I try. Okay, it worked. The camera didn't move. That's good. But it's not really a good solution. Let's say we have multiple levels, and each of the levels have different player starts. So let's say one here, one there. We can't realistically go in all of our levels and like copy paste all these variables every time the player start moves. It's not the right way to do it. So let's delete this one and that one. I'm just gonna keep this little one right there. So right now if I press play, since I moved it, the camera should move around. Here we go. You can see it flicker a bit. It's annoying. It's not good. Okay, let's fix this. I'm gonna go back in the pawn. How do we do that? So what do we know? We know that the player spawns at the player start location, and then it starts to interpolate towards the desired location. So technically, on the first frame, the pawn is on the right location, but it starts to move afterwards, which makes it flicker. So the solution will be to take a snapshot of the current location of the actor at the first frame, and then feed it into our desired location. Then all of our movements are going to be added on top of that desired location. So let's see if it works. To have access to the first frame, it's the begin play. So right above the tick, I'm going to create the event begin play. So begin play, event begin play. It is going to be called the first frame the actor spawns into the world. And since we know the actor spawns at the player start, that's what we want. Then I'm going to copy the get actor location right here. I'm going to take my location desired on the left and drag it into the graph and click on set. I'm gonna hook them together and hook it to the begin play. And that should fix the problem. Let's try it. So compile, save, go back in the level, press play. My camera starts where the player start is. That's good. I'm gonna stop. Move around, play again. My camera is back at the right location. Great. Okay, I can still move around and that works perfectly. Okay, let's try another thing. If I move this player start right there instead. If I press play, okay, my camera is moved right there when I press play. Good. So I'm just going to center my player start back in the middle of the level. And that fixed the problem. Which makes me think we can probably do the same thing for the zoom. If you remember, in the zoom here, it wasn't working because the zoom desired value on the right there, was not the same as the spring arm target arm length in the component. Which means that every time we go back, let's say in the viewpoint right here, and we scale that back up, it's not gonna work anymore until we take that value, copy it, and paste it into the zoom desired right there. Which is something that is a bit annoying and that we can easily avoid. So let's do it. In the spring arm, I'm going to reset this to 700, let's say. And then I'm going back in the event graph. I'm going to get the spring arm, get the target arm length from the spring arm, and I'm going to use it to set the desired zoom on begin play. So drag into the graph, set desired zoom, connect them together, and connect the white pin. Here we go. So that should fix the problem. first let's check if it didn't break anything. So compile, save, go back in the level, press play. Everything seemed to work. I can zoom out and zoom back in perfectly. Good. Back in the pawn. If I go in the viewport, go to the spring arm and set the length to, let's say, 150. Compile, save. Go back in the level, press play. I'm way closer now. That's good. If I go back in the pawn, now I can do the opposite. I can make it super far. So 1700. Then I press play, I'm super far. And the camera doesn't flicker. So that's good. So now we can go back in the pawn, reset that value to 700 because I liked it. Compile and save. The last thing we have to do is the camera rotation, which is going to be pretty similar to what we have for the location and the zoom, but also a little bit different because it's more complex. So same as before, the first step is to create the events in the input settings, so project settings, and here we have all of our axis mapping. We could add another axis mapping right here and treat it the same way that we did for the input forward and right. But I want to do something a little bit different. I want to have a rotation that rotates a certain amount every time I press the button. So let's say I tap the button, I rotate 45 degrees. I tap again, I rotate another 45 degrees. So I press once and then it snaps to the right rotation angle that I want. We could do it with an axis, but it's going to be better with an action mapping. So let's add another action mapping. As for the name, I'm going to name it input action underscore rotation right. For the key, I'm going to use E on my keyboard and look for it. Here we go. So when I press E on my keyboard, I'm going to rotate 45 degrees on the right. Now for the left side, we need another action mapping. So action mapping, input action underscore rotation left. And for the key, I'm going to use Q. Here we go. Let's go back to the pawn. We can go at the bottom and call our events. So action, rotate right, and action, rotate left. We can see that the action nodes are different than the axis nodes. And this is because the action node are only called twice. Once when the key is pressed and once when the key is released. Compared to the axis event that is called every frame with a value that lets you know if the key is pressed or not. But in our case, that's exactly what we want. When the key is pressed, we rotate the camera, and that's it. So let's do this. First, we need a variable to set the desired rotation. So we're going to create one. Create new variable. For the name, I'm going to name it rotation underscore desired. As for the type of the variable, we don't want to use a vector. We don't want to use a float. There's something in Unreal that is called a rotator, and it's used for all the rotations in the game. So let's select rotator. We can then compile the blueprint. Once compiled, on the right side, we can see that it's pretty much like a vector, but it also contains a few things that are specific to the rotations. But let's not worry about that for now. So we have to get our desired rotation. Let's do this. Desired rotation, get. And then set. Then we can connect the set to the event. Then we need to add to the desired rotation every time we press on that button. So I'm going to look for plus, which doesn't give me anything because we can't really add rotations together. But there's a little something that is called combine rotators. It's pretty much the same. It's going to add the rotations together for us. So let's use that and connect it to the set desired rotation. As for the rotation amount, let's say I wanted to rotate 45 degrees and I want to do it on the z-axis, so 45 degrees. So every time I press on the rotation right key on my keyboard, it's going to take the rotation desired, add the 45 degrees to it, and set it back to the rotation desired. I'm going to copy paste those nodes and attach them to the rotation left. And instead of the 45 degrees right here, I'm going to type minus 45 degrees. So it's going to go the opposite direction. Now let's use that value to rotate the camera. So I'm going back into the tick. Instead of a get actor location, I'm going to do a get actor rotation. Instead of the set actor location, it's going to be set actor rotation. I'm going to attach it right here. And I need a little bit of space, so I'm gonna make some. Here we go. Then if I drag out of the get actor rotation, I can have access to the R-interp2, which is the interpolation node for rotators. Here we go. So the current is the get actor rotation. The target is the rotation desired that we have right here. The delta time is the delta seconds from the tick. And the interp speed, let's say 5. Doesn't really matter. And then I can take the return value and connect it to the new rotation of the actor. Okay, so let's try this. Compile, save, go back in the level, press play. Okay, I can move, great, I can zoom out, zoom in, good. Then if I press E, okay, it rotates. Not in the right direction, but it rotates. E again, okay, Q, Q, okay, that's fine, like, it makes sense. It's just inverted. Okay, good, let's go fix this. Go back in the pawn, I'm gonna go all the way down here. When we said 45 minus 45, we're gonna do the opposite. So minus 45 and 45. So let's compile, save, go back in the level, press play. 45, good, okay. So that makes more sense. But now what happens if I rotate my player start? Let's do something like this. Press play. Okay, the camera flickers and it's not oriented the right way. I'm gonna stop, play again. We can see the flicker and the camera is not oriented the same way as the player start. That's not what we want. We want it to be the same. So we're going to go back in the pawn and do the same thing that we did in the begin play for our rotation. So copy paste the actor rotation right here. And I'm going to set the rotation desired based on the actor rotation on the begin play. And that should fix the problem. So compile, save, go back in the level, press play. And now I'm oriented properly. That's good. But now what happens if you press forward? You move diagonally. What if backwards? Diagonally again. Same thing with right and left. Okay. What if we turn a little bit more and then you press forward? Oh, that's odd. Backwards? That's not good. Okay. Right, left. Okay. And if you turn even more, it's even worse. And now it's just confusing. Okay. We have to fix that. So back in the editor, I'm just going to select the player start as an example. And I'm going to reset the rotation. Right here, we can see that the player start is facing that way with the blue arrow right there. And if I move it in the EX, it goes forward and backward. That's fine. And then if I go in the Y, it's go right and left, which is good. That's perfect. Okay. But what happens if we rotate the player start? So let's say I'm rotating it 45 degrees right there. Then if I move it forward, it goes diagonally. And same thing if I go right and left. And this is because we're moving the actor based on the default direction system of Unreal and not based on the direction in which the actor is looking at. So what we have to do is to use the actor rotation when we are moving it to make sure we are moving it in the right direction. If you are in the editor, it's pretty easy to do. You can simply click on this icon right here to toggle between the local space and the world space. When you're in local space, if you move forward and backward, it follows the direction at which the player start is looking. And it follows if you rotate it. So let's say I rotate it again, that direction, and then I can see that my forward is still that direction. And that's exactly the same behavior that we want for our pawn. So let's do it. I'm going to reset the player start for now and go back in the pawn. So when we are setting the location desired at the bottom, right here, right now we are adding an offset to the X coordinate when we are pressing the forward key. And we're doing the same thing for the Y coordinate for the right and left keys. But instead of doing that, we are going to use the right and forward vector of the actor to determine which axis we want to increment. And it's pretty easy to do. For the forward, we simply have to right click and look for get actor forward vector right here. So this is the direction in which the actor is looking. Then we can multiply this vector by a float, so vector times float. So the float will be the amount we want to move, so it's gonna be the forward axis times the speed right here. And then we have to connect the result to that addition right there, but we can't, because the vector is split in three. To recombine them, we first have to disconnect all the pins that are connected, so this one. And we can do that by right-clicking on it, and click on break link to float times float. But it's a bit slow and we should use the shortcut. So I'm going to Control Z. The right way to do it is to hold down the Alt key and click on the link, which is way faster. Then we can right click on any of the pins and click on recombine struct pin, which gives us back our vector, which we can connect to the result of the multiplication. Let's quickly do the same thing for the right axis. So we need the right vector this time, so get actor right vector that we want to multiply with a float, so times float, connected to the speed. Then we have to break with the Alt key and clicking on the link, right click on any pin and click on recombine struct pin, connect the vector to the addition, and that's it. So right now the camera should be fixed. Let's compile, save, and go see. So if I press play, if I go backward, forward, left, right, that's good. If I press E to rotate, then I can press forward, backward, left, right. It's all good so far. E again, forward, backward, left, right. And again, forward, backward, left, right. And again. So now we have a working camera in all angles. Great! You can always go back in the pawn and tweak all the values if you want. So there's the speed of the zoom, the speed of the location, the increment of rotation, and also the interspeed of all those. But for now it's time to end this video, so I'm going to save everything and go submit my assets in Sourcetree. Here in Sourcetree I have my default input that contains all the changes to the input that we did, the player pawn, the player controller, and the level. So I'm going to stage all that, create my comment, so setup, camera controls, and click on commit to end this video. So bye bye!